I invented a method to create vascularized human tissues. My invention is utilizing 3D printing to simultaneously pattern cells, vasculature, and extracellular matrix into realistic human tissues. My invention works by making a series of inks, some that are cell-laden, some that are extracellular matrix, the material that binds and holds your tissue together, and another ink for printing vasculature. Tissue engineers for decades have been trying to figure out how you can actually recreate pieces of tissue in the lab. But for decades, they've struggled with how do you make vascular networks to support the cells in your outer tissue. We think we found a way to incorporate this vasculature and help keep very dense, thick tissues alive long term. I'm honored to be a part of a competition that celebrates collegiate invention. I think the more you can encourage young people to go out and try to change the world, the better. And I think it can only have an effect of even inspiring future generations of invention. And I'm very proud to be a finalist in this competition.
Premature babies often struggle to keep their lungs open and breathe. The functional unit of the lungs, the alveoli, are like small balloons, which are hard to inflate the first time.
Sicker babies require a dual-level treatment that's typically not available in low-resource centers because they don't have access to ventilators.
Our device collects bubbles, rises, and sinks. This process repeats, delivering 2 levels of pressure to the infant, a high and a low. We are harvesting the waste bubble energy of current treatments to power the next level of treatments.
The device is simple. There's just one moving part, and the delivered pressure is set by the depth of water in the container. As the nurse is walking by, she can look and see, are there bubbles coming? Is the device moving? And know the baby's receiving the correct treatment. So just by switching your exhaust pipe to a pipe with our device mounted on it, you can now deliver the next level of treatment at a price point of $25 as opposed to thousands of dollars for a ventilator.
Our invention SWAPS is an optical switch device. Optical switches are the devices that switch the connection between optical fibers. With optical switches, you can dynamically disconnect and reconnect the optical fibers according to the traffic demand, so your network can manage the data traffic in optical fibers more efficiently. Optical switches are one of the key components for running data center network energy efficiently. However, commercially available optical switches are slow and expensive. Our invention SWAPS is 1,000 times faster than commercially available optical switches, and our SWAPS can be produced in microelectronics manufacturing technology, which promises low cost and high yield.
We invented Highlight in response to the Ebola crisis of last year, where healthcare workers were volunteering their own lives essentially to help save other people, but becoming too vulnerable to infection themselves.
During the recent Ebola crisis, 1 out of every 20 deaths was of a doctor, and these deaths occurred because of ineffective decontamination. Highlight fixes that gap and guarantees that whether you're working with infectious agents in a hazmat unit in New York City or with MERS in Saudi Arabia, your healthcare workers will be protected.
Highlight is a powdered additive that can be mixed into the disinfectant of your choice. What it does is it enhances the process of decontamination.
All you do is simply pour the contents of the bottle into a contractor sprayer, you mix it up, and then you spray.
I've always been excited to participate and contribute to inventing new things that could help other people.
I think all the work that everyone is doing across the board is awe-inspiring. It's awesome to see so many cool, interesting projects that really are addressing specific pain points around the world.
Inventing allows me to stand at the forefront of technology to come up with innovative ways to solve problems in our everyday life. Counterfeiting has become a huge global concern. it causes a loss of around $650 billion every year. My invention is a molecularly encrypted fluorescent security inks. These inks can be printed using just a simple inkjet printer to produce images or barcodes on anything from banknotes to whiskey bottles to luxury handbags, and you name it. You can authenticate these images by simply shining a UV light on them, just like what you would normally do to authenticate a banknote. I personally have been a victim of counterfeit products many times. So it then became apparent to me that we need a more advanced technology to fight against counterfeiters more effectively, and that's where my security inks would come in. I have a lot of respect for my young, innovative peers. I am amazed by the way they think and the approach they take to solve problems. They give me this self-assurance and courage to keep going in the journey of invention and innovation.
So our invention is TokaTrack, which is a low-cost uterine contraction monitor. It essentially allows for midwives and nurses in low-resource settings to be able to track the uterine activity of a pregnant woman in labor and allow for them to be able to detect any complication that may arise.
Basically, a midwife comes by, she takes the device, she straps it onto the patient, then she can turn it on, check it's in the correct position, come back in, say, 10-20 minutes when it's done recording data, and then she copies that data onto the partograph.
So every year in low-resource settings, roughly 90,000 women die from two different complications, one being prolonged labor and the other being obstructed labor. Both of these complications can be detected by our device, and there are enough resources at these clinics to intervene accordingly.
I think it's great seeing so many students and young people feel so driven and have so much interest in identifying and solving clinical problems and other problems in the world.
Traditional two-dimensional cell culture models fail to represent the structural complexity of the human eye. As such, ocular research has primarily depended on animal studies for drug development and toxicity screening.
To address this serious lack of physiological research platforms, we have developed a micro-engineered organoleptic model of the human eye that replicates the three-dimensional architecture and dynamic microenvironment in the ocular surface.
Our passion for inventing has been inspired by our friends, classmates, and mentors. We are honored to have been selected for this competition and are excited to meet our fellow finalists to learn about their inventions.
My invention is a Dropbase microfluidics platform for the early diagnosis of cancers. And basically what this platform does is that it encapsulates single cells from the bloodstream. And by using this technique, this is a quantitative way both to detect and isolate cancer cells, which is useful for both diagnosis and treatment. The reason I especially love both innovating as well as science is that when you put these two disciplines together, you can actually create solutions to everyday problems that move the human race forward. And I think my innovation is a very, very small step towards cancer diagnosis and cancer therapy, which in the long term can potentially allow for very, very early diagnosis of cancers.
Our invention is a low-cost programmable electronic stethoscope that can be used in any type of noise environment or clinical setting to improve lung sound analysis, both domestically and abroad.
We aim at improving the diagnosis of pneumonia or other respiratory illnesses in remote settings or developing countries where access to healthcare personnel is limited.
My peers are working on some very innovative solutions to problems. Every single one of them is going to go on to do some amazing things and change their field to ensure a better tomorrow.
We represent Team Cyclic Solutions from Lehigh University. We are currently working on the development of an HIV viral load test for use at the point of care. We present a novel method of HIV viral load testing that has the potential to be much less expensive than current systems on the market.
At Cyclic Solutions, the next steps in our development pipeline are to improve manufacturability of our device as well as develop systems integration and instrumentation. With these developments, it is our hope that we will be one step closer to translating our device into the clinic.
I invented a computer that operates on water droplets, similar to an electronic computer that manipulates streams of electrons, millions, trillions of them, to manipulate information. My computer employs the same ideas to manipulate droplets around, to move them across certain directions or store them in specific locations. A droplet for a biologist or a chemist who wants to do simple and well-understood problems is a grocery bag in the microscope. You can put materials of interest, DNA, RNA, enzymes, proteins. And then what you can do is that you can take experiments that traditionally are done in big labs and they can take 3 months, 6 months. And just by employing this droplet computer that can do these operations very fast and very efficiently, moving tens of thousands of these droplets simultaneously, you can bring these times potentially from 3 months to 1 week or a couple of days. What really excites me about science and invention? Well, for me, first of all, it's like picklocking the mysteries of nature and bringing it to a form that is useful for mankind.
Contraline is the first non-surgical contraception for male cats and dogs as an alternative to neutering. Neutering has been performed by veterinarians for centuries. Recent research, though, shows that neutering may not be the safest and healthiest option for your pet.
They won't be able to reproduce while this is in them, but you could remove it at any point in time, so it's a lot more like a contraceptive.
Contraline is a polymer gel that is inserted into the vas deferens of the animal, or the tube that transports sperm. The gel acts as an occlusion, blocking the flow of sperm for years.
So if you can take this huge standard procedure that everyone's doing and give people a better way to do it that's going to be healthier for their pets and allow them to live longer and have more active lives, that's just such an awesome experience for the pet owner and for the pet itself.
I think it's really amazing to be able to break down a problem and figure out new ways to think about it.
I love inventing because you get to take a problem and just reimagine the way that you approach it to begin with.
My invention is a corrosion-resistant molecular coating that is a monolayer of an iridium-containing molecule that prevents corrosion of metals and metal oxides and polymer materials from harsh conditions.
So this invention is going to change the world by reducing waste in different agricultural processes and refining processes and in energy storage processes. This invention is going to change the world by stopping oil spills from happening due to corrosion from the inside out of the pipes. This invention is going to change the world by preventing spills of different sorts of fossil fuel related materials that are highly corrosive and move through pipes at some point or another.
Our invention is called Q-Through. It's an automated build plate for 3D printers. Currently, a person needs to be present every time a 3D printer finishes making a part. They need to be there so that they can remove the finished part and then start the next one. And obviously, this ends up being a pretty huge waste of time when you have a lot of parts to make in a row. With Q-Through installed, a 3D printer is able to build parts in succession, which means that it can print all day, all night, without ever needing a person to come by and interact with the machine.
We hope that the widespread adaptation of our automated printing add-on will make the future of 3D printing more accessible by making the entire process easier, more efficient, and more reliable.